Hi, we've made it, day 4 of Neutrino Day. Today we are going to read a book by Stella Latta. You will have an opportunity throughout the time the book is being read and shortly after to post any questions that you have in the chat. We have a dark matter scientist who will be joining us to answer all of your dark matter questions. So use all the things that you've been wondering about and all the things that you're curious about. We would love to see a ton of questions. Then, when this is all finished, you will have an opportunity to take all of those materials that you have been collecting around your house and do an experiment to find out what it is like to try to explain something that you cannot see. It will be a challenge not only of your observational skills, but it will also be a challenge of your communication skills. And finally, I want to let all of our viewers know that if you submit a question today, you are going to be entered into a drawing. The author of Stella, Brite, and the Dark Matter Mystery is going to be sending out 2 signed copies of her book. So make sure you get your questions in the chat for that especially. Okay, so we have Stella, Brite, and the Dark Matter Mystery, written by Stella Latta and illustrated by Meredith Johnson. Snap. Stella Brite popped her bubble gum. Mayor Pickles' Pekingese has been on the loose for a week now. If he could just track down that tricky puppy, everyone in town would know about the Brite and Brite Detective Agency. Stella's brother Max came running in and waved a newspaper in her face. "Stella, put the mayor's pooch on hold," he shouted. "This is the case of a lifetime." "Mysterious missing matter?" Stella exclaimed. "Let's take the case, Max." She grabbed her detective backpack. "We'll start by doing a routine background check at the library," she said. She threw some doggy biscuits into her pack, just in case, she added. At the library, Max found a book called The Universal Encyclopedia of Everything. "This has got to have something," he said. "Let's take a look at these too," Stella said. Later, Stella and Max compared notes at Zwicky's Pizzeria. Stella asked, "So, did you find anything out about dark matter?" "Matter is anything that has mass," Max said. "I'm matter. So is this pizza. And mass is the amount of stuff in an object." He looked hopefully at the pizza. "If I could have that last slice of pizza, I'd have more mass." "And a bellyache," Stella said. "Look over there." When Max turned, she hid the pizza under the table. "I don't see anything," said Max. "Hey, where'd the pizza go?" "It's here," Stella said, laughing. "You just can't see it. It's like dark matter. Scientists think dark matter should exist, but they can't find it." She gave Max the pizza. "We're going to find that matter, Max, and I know where to look." She tapped a flyer on the wall. "The astronomy club meets tonight at Lookout Hill. Let's go." At the top of Lookout Hill, kids were looking through telescopes of all sizes. A tall boy named Ben let Max have a look. Max called out, "Hey, I see Jupiter and 4 of its moons." Ben nodded. "Jupiter is really big, so it has a really strong gravitational pull. Its gravity holds more than 30 moons in orbit." "So the moons go around Jupiter while Jupiter goes around the sun," said Max. "Does the sun go around anything?" "The sun goes around the center of the galaxy, just like all the other stars of the Milky Way," answered Ben. "That must be some powerful gravity that keeps all the stars together," Stella said. "Actually, that's the funny thing," Ben said. "Based on the stuff we know, there isn't enough mass to hold our galaxy together. The stars and gases on the edge should go flying off into space, but they don't." Stella blew a big bubble and popped it with a bang. "Galloping galaxies, that's it," she said. "Scientists think there's some invisible matter holding galaxy together, right?" "Well, it could be dark matter." Max looked puzzled. Stella pulled out a yo-yo. "Close your eyes," she said. She stepped behind a row of bushes and again whirling the yo-yo above her head. "Okay, where am I?" "You're behind the bushes, of course," Max said. "Oh, I get it. You're like the missing dark matter. I can't see you, but I know you must be there holding on to the yo-yo." "So dark matter holds galaxies together," Stella said. "But what is it exactly?" Ben shrugged. "I don't have a clue, but there's a person to ask." He pointed to a shadowy figure darting through the trees. "Just be careful," he warned. Stella and Max looked at each other. The mysterious figure disappeared into the darkness. "Let's tail her," Stella said. "She must be up to something." Stella and Max followed the mysterious figure into a large brick building. In the dim light, they saw a thin woman hurry down the hallway and slip into an office. A sign on the door read, "Professor Bella Black." Soon the woman rushed out, leaving the door ajar. "Now's our chance," whispered Stella. "Let's see what, or who, is inside." Max gulped and followed. The only signs of life in the room were 2 parrots and a goldfish. "Looks like the coast is clear," Stella said. "Time to hunt for clues. What is dark matter anyway?" "Wimps!" screamed the green parrot. Max jumped. "Who are you calling a wimp?" he demanded. "Macaws!" screeched the red parrot. "Yeah, you two are machos all right," muttered Stella. "Why don't you bird brains be quiet?" "Wait a minute," Max said, holding up a book called The Weird, Wild World of Wimps. "Maybe these parrots know something we don't." The green parrot bobbed its head. "Wimps!" it screeched. Max grabbed another book. "And look at this, Machos and the Hunt for Dark Matter." "Machos," the red parrot squawked. Max flipped through the book. Suddenly he laughed. Macho stands for Massive Compact Halo Object. Machos are invisible objects with lots of mass, maybe old dying stars. They don't give off any light, so it's really hard to detect them. I wonder how people know they're there. "I think that's what this picture shows," Stella said, pointing to a diagram on the board. "Here, the macho in the middle is gravity bending light waves coming from a star." Max looked skeptical. "How can light bend?" he asked. Stella stepped behind the fishbowl. "Tell me what you see, Max." Max peered into the fishbowl. Stella and the goldfish peered back at him. "I see you and the fish," he said, "but you look funny." "That's because the fishbowl is curved like the lens in a pair of eyeglasses. They both bend light waves," Stella said. "The gravity of a macho can bend light waves too." "It's like you and the yo-yo," Max exclaimed. "We can't see the macho, but we can see what it does to something else." "Macho, macho," screeched the parrot triumphantly. "Shh," Stella hissed. "Keep it down." Stella returned to the picture on the board. Here you're looking at a star through a telescope, and it looks normal. But suppose a macho sits between you and the star. The starlight bends around the macho. Here on Earth, we can see the bent light rays combined together. Stella chewed her gum furiously. "I can't imagine how it would look." "Maybe it would look like this," Max said, pointing to a poster. "Brighter, because all that light adds up." "Brilliant detective work, Max," Stella said. "When the star gets brighter, it's a clue that there's a macho lurking about." Max looked more closely at the poster. "Don't celebrate yet, Stella. The poster says that machos make up only 20% of the dark matter in the Milky Way. If that's true, then where's the rest of the dark matter?" At that moment, a scratchy voice interrupted them. "What exactly is going on here?" Stella and Max gasped and ducked behind a cabinet. Peeking out, they saw the thin woman talking on a cell phone. "I scheduled the dark matter hunt for tomorrow morning at 7 a.m. I expect the equipment to be at the old mine by that time. Please see that it's ready." She hung up and turned to the parrots. "And now it's time for you to go to bed, Einstein." She covered the green parrot's cage with a cloth. "Wimps," came from behind the cloth. "You too, Vera." "Machos," said the red parrot in a muffled voice. "Good night, Newton," Professor Black told the goldfish. She picked up her briefcase and hurried out the door. Stella and Max grinned at each other. "Maybe she's not so bad after all," Max said. "She likes animals." "And she gets up early," Stella added. "I wonder if we can get some pancakes with the dark matter." The next morning, Stella and Max biked out to the old mine. They hid and waited. Soon Professor Black appeared, leading a group of sleepy students. "Listen up," she barked. "We're here to hunt for dark matter particles called WIMPs, weakly interacting massive particles. The hunt won't be easy. WIMPs have a lot of mass, but they're tiny. They're like ghosts that can pass through the entire Earth. In fact, hundreds of millions of them are passing through your bodies right now. If they exist, that is." "What makes you think they exist?" a student asked. Professor Black held up a picture. "This shows the X-rays emitted by a giant cloud of hot gas 4 billion light years away. It yields valuable clues about dark matter." Stella leaned forward so that she could see the picture. Suddenly, she felt herself slipping. Crash! Stella landed on the ground at the professor's feet. What is this? Who are you? Professor Black demanded. Stella scrambled to her feet and held out her hand. Good morning, Professor. I'm Stella Brite of the Brite and Brite Detective Agency. My assistant Max and I are trying to resolve the case of the missing dark matter. Professor Black raised an eyebrow. Stella and Max, eh? This morning my parent Einstein told me that Stella and Max are wimps. Stella turned red, but she continued. Our apologies for snooping, Professor, but we learned the facts about Macaws, and now, thanks to your picture here, we understand the evidence for wimps. We do? Asked Max, coming out of hiding. Stella explained, it's like seeing a city from an airplane at night. The X-rays are like the lights on the buildings, and the buildings themselves, the matter holding the lights in place, are invisible. An interesting way to put it, Professor Black said thoughtfully. Stella continued, and because the gas is glowing really close together near the center, the dark matter holding it in place must be really small. Small, but with a lot of mass, like a wimp. Professor Black smiled. Exactly, she said. Now come with me, everyone, she ordered, leading them into an elevator. Here on the surface of the Earth, we're constantly bombarded by cosmic rays from outer space. These particles would interfere with our experiment, so we use the Earth as a filter. It blocks cosmic rays, but lets wimps pass through. Wimps rarely bump into anything, Professor Black continued. But when, and if they do, we hope to hear them. If a wimp bumps into one of the atoms of our crystal detector, our instruments should pick up a little plink. The elevator came to a stop. Professor Black led the way into a giant cavern. And now, ace detectives, welcome to our lab. You can help us look, or should I say listen, for wimps. Stella and Max listened, and listened, and listened some more. The day went by without so much as a single wimp ping, but Professor Black was cheerful. Wimps are elusive, but if they're there, we'll find them. You can come back and help any time, Detectives Brite. Thanks, said Stella. This case isn't closed yet, Professor. As they biked home, Max sighed. Finding dark matter is a lot harder than I thought. Yeah, Stella agreed. But now we know a lot more about the way the universe works, and we'll stay on the dark matter case no matter how long it takes. Solving scientific mysteries is a lot harder than tracking down missing dogs, that's for sure. Speaking of missing dogs, Max said, getting off his bike, see how that bush is shaking, even though there's no wind? I think I know what's moving it. It's like dark matter. I can't see it, but I can see what it does. And he dove into the bush. After a brief scuffle, Max emerged holding a small brown dog. The dog wagged its tail and looked hopefully at Stella. Mirror Pickles Pekingese, she cried, scooping up the dog. You pesky peaky, it's a good thing we found you. She checked her backpack. Or maybe you found us. Okay, so through our story, you learned just a little bit more about the dark matter mystery and some of the things that we're trying to find about the universe. This is your opportunity, if you have not already entered your question into the chat, to get your dark matter questions answered by our dark matter scientist. So I am joined today by Doug Tietz. He is a member of the LZ team, and he will answer your questions and tell you a little bit more about the project.
Hi, thank you, Julie.
All right, so we have one question from the audience. Are the dark matter experiments at Sanford Lab hoping to find wimps or Macaws or maybe both?
So the experiment here at SURF is the Lux Zeppelin or LZ experiment, and it's designed to look for wimps. There's two very different approaches for looking for these types of dark matter. For a Macaw, you basically want a telescope. You literally just want to look out in the night sky, look at a bunch of stars, and just keep looking at them. Because if a Macaw passes between us and the star, you should see a little blip of light. The star will get a little bit brighter. And so you just map out the night sky and keep a catalog of how bright all the stars are, looking for that signature beep. For something like a WIMP, though, you want a detector where you're looking for the WIMP actually interacting with other bits of matter. So LZ, it's located deep underground here to shield itself from as much other things that might want to interact with your detector. and it's looking for these very subtle WIMP interactions.
Great. We have one other question. If you can't see dark matter, how do you know for sure that it exists?
So there's a lot of very different, mostly astronomy-related reasons why we think it's out there. Early on in the 30s, a man named Fritz Zwicky, he was looking at how fast galaxy clusters were spinning around each other, and things just seemed a little bit off. And he coined the phrase dark matter, and it sat around for a little while. And then later on, a lady named Vera Rubin, she was looking at the rotation of galaxies instead, so a little bit smaller scale. And she also saw that the math didn't seem quite right. Basically, as you look out from the center of a galaxy out towards its edges, you expect the speed of the stars spinning around to drop off, because otherwise they would just fly out into space. And what you actually see, doesn't matter which galaxy you look at in the universe that we can see, it actually sort of just flattens out. And the stars are just going fast and fast and fast as far out as you can see them. And the only good way to explain this is because there's some matter holding it together and binding it that you can't actually see. There are also cases, like the bullet cluster is a very pretty example. I recommend looking that up because it looks very cool, which is a case where two galaxy clusters actually pass through each other. And what you can see on, say, an X-ray telescope is you can see where all the hot hydrogen gas is, which is where most of the mass in a galaxy cluster should be. You can actually see that that gas slowed down and kind of stopped as the rest of the galaxies and galaxy clusters went flying off. And you would expect, if you look for gravitational lensing like we mentioned with the Macaws, you would expect that the light would be bending mostly around that center gas, if that's where all the mass is. But if you actually look at where the lensing has happened, and you can map out where the actual matter is, or the mass, you can actually see that the mass of those galaxy clusters didn't slow down. It kept going, which implies that there's some other, this dark matter that doesn't really interact with anything, but has a very strong gravitational pull.
Great. Another question is, what other things besides Macaws and WIMPs might make up dark matter?
So the other big one that a lot of people are looking for is something called an axion, which is closer to WIMPs than it is Macaws. It's basically a small particle that may decay into light in very broad terms. So there are experiments that are basically making resonant cavities so that the light can bounce around inside of the cavity as long as possible. And they're just looking for that light to decay into an axion, or an axion to decay into a photon that they can see. And there are a number of those experiments around the world too, looking for those. But they're a very different sort of experiment. They don't need to build a big, massive detector. They just need to build basically a very sensitive antenna that they can tune until they hit the magic frequency where the axions might resonate.
Awesome. Another question is, what reaction will you see if dark matter is detected in LZ?
So what LZ is looking for is a nuclear recoil between a WIMP and a xenon nucleus. The reason we use xenon specifically is when it gets hit by something, it likes to scintillate and emit a bit of light along with a shower of electrons. So if a WIMP hits our xenon, we'll get a burst of light, and our detector is filled with these light-sensitive photomultiplier tubes that can see single photons of light, and that will give us our first signal. We also have a very strong electric field, and we actually drag these electrons up to the top of the detector, and when they pop out of the liquid xenon into a little bit of gas we have at the top, we actually get a second burst of light. And this sort of characteristic two bursts of light lets us tell what type of interaction it was, whether it was a WIMP particle hitting something or whether it was just some other kind of radioactive decay. And it also lets us build this 3D image of the interaction inside of your detector. So it's not just seeing like a single blip. We can actually map out where things are happening and what's happening in our detector. And by knowing exactly what sort of radioactive backgrounds or other things we know, we can, when we see something we don't expect, that's when we can start thinking about, is this dark matter?
Great. Another one asks, how long will you run the experiment looking for WIMPs?
So the goal for LZ is to take data for about 5 years. So we're hoping to start taking data hopefully by the end of this year or early next year. And so we'll probably keep taking data into 2025 or 2026.
Terrific. It looks like that's all the questions we have from the audience.
Excellent. So now it's time for the audience to switch gears, and you are going to put yourself into the role of investigator. If you have your investigator notebook, you can certainly keep notes that you can turn in for your prize pack. But what I want you to do is I want you to get ready for all the materials that you collected over the week. If you have not yet collected your materials, you can press pause on this presentation. It will be available later. And when you have all the items in front of you, you'll still get an opportunity to do the experiment and ask the questions. If you have all of your items gathered, I want you to be thinking about dark matter. And though we can't see it, we know that its presence is made known by the way that it interacts with normal matter. And so some of the normal matter that I have collected, I'm going to separate into 2 piles. I'm going to have one set of materials for each of my jars. So I want you to go ahead and put your materials into your jar. You're going to make 2 of them that are roughly similar. And then what you're going to do is you're going to take your water and you are going to fill one of the jars as full as you possibly can, and don't leave room for air. Okay. Once you have your jar full, you're going to put on the lid, and know that when you put on the lid, it may spill just a little bit of water, and that's okay. That's why you have your paper towels handy. You can take the jar without water, and you can simply put on the lid, because what's coming next is going to be a comparison. Now you know, because you just added water to your jar, that it's there. But the challenge for you now is going to be to explain what you see when you look at these 2 jars. Now I want you to take a minute and look at them, do some comparisons, see what you can see. If you put your lid on tightly, you can even look at them upside down. Take just a minute now and look at the objects in your jar and tell me how you know that there's water in this jar. What observations can you make to explain this to somebody? Now I know this is challenging because water is clear and technically the water is invisible. But what can you see? Now I have to tell you, one of the things that I noticed right away when I added these jars is that if I look at the jar that has no water in it, the cork, which is the object I chose as my floating object, is sitting on the bottom of the jar. But in order for me to see the cork in the second jar, I actually need to look up from the bottom. And now that I'm looking up, I can actually see that I have 2 beads that are also floating near the top of my jar. The jar without the water, the jar that's only normal matter, they're all sitting at the bottom. The other thing that you might notice is that one of these jars is definitely heavier than the other. And if you're thinking about some of the evidence for dark matter, that's one thing you might notice, is that there is extra mass or missing mass in these jars. And though I can't see it, I know that it's there. The other thing that's interesting, do you remember in the book when Stella looked through the fishbowl and she looked different? I can notice some of that in my jar with the water too. So I happen to have a penny in the bottom of this jar, but it is stretched out just a little bit. It doesn't look quite like the penny does in the jar that has nothing in it. And the last thing that I noticed is that these objects behave differently. If I turn these upside down, these fall to the bottom very quickly. These tend to fall a little more slowly, and I can see my floating objects now floating when I turn them upside down. Now, one of the things that I don't expect you to have, but I really wanted to try, when I was looking around my house for objects, I actually found this really fun confetti, and it's made of stars. And I wondered what that would do in my setup. And since we have a universe full of stars, we might as well try our hand at that. So if I add my star confetti, my jar with no water, my dark matter representative, they all sink to the bottom. But if you look closely, you might notice that none of those sunk to the bottom when I added them to the jar that was full of the water, which is acting like our dark matter in this case. But if I turn my jar upside down, you'll notice that some of them begin to float and move within the water. And so while we cannot see the water itself, we can definitely see the way that it reacts with things that are inside that. So in addition to one being heavier and one bending light, I want to leave you with one final challenge. Now, in the book, you saw some images of light bending around a star. And observing that is an interesting challenge. I'm going to leave you with something that I would like for you to think about how you would use your science vocabulary to explain. On this piece of paper, I've just drawn an arrow with a black marker, so nothing too fancy. But when I put this arrow right behind the jar, I can see one thing. And one of the things that I see looks just like the arrow did when it was written on the paper. But the thing that's interesting is when you start to move your paper a little bit away from your jar, you notice something unusual happening. And that's the thing I want you to work on explaining from home. Now, I hope that you have piqued your curiosity about dark matter. I hope that you are challenging yourself with your observations about something that is essentially invisible and how it interacts with other things in our universe. And we hope that maybe someday we'll see you at the Sanford Lab.